Make me co-host access. I'm unable to share screen. Hi friends, good evening. So welcome to the Automotive Analytics by 360DigiTMG. So in the previous classes, we have discussed about what are the applications of automotive analytics and applications. So for the first day, we discussed about the applications in the automotive industry. And especially it is to analyze the existing customer and implementation in the product cycle and etc. So these are the applications we discussed in our first class. Then discussed about CRISP-MLQ methodology. So it is also called project management methodology. So it has 6 steps, starting from business and data understanding, data engineering, model building, evaluation, deployment, and monitoring and maintenance. And we discussed also regarding data engineering, nothing but ED and pre-processing, and discussed about 2 types of learning, supervised learning and unsupervised learning. Unsupervised learning, so you can say there is no output variable. Just model can give rules or patterns. So when any new data points comes, it can predict which cluster. Unsupervised algorithm also called as clustering algorithm. So when new data point comes, so it will suggest the data point is belongs to which cluster, etc. Now coming to the supervised learning algorithm, supervised algorithm. So here we have output variable and the results based on the features. So supervised algorithm, and it will give the accurate results. It will give the output variable with respect to some different inputs. So machine can understand the behavior of the patterns and it will give the correct output for the particular inputs. And supervised algorithm, different algorithms we have in supervisor, classification models and regression models. So today we are starting supervisor learning algorithm. So as we discussed, so supervisor nothing but model performance. So model built on label data. So we have labels here, and based on the labels, so even new data points comes, we can predict the value. So today we will discuss about KNN. KNN also nothing but K nearest neighbor. So it is classification model. So today we are discussing about KNN classification model. Right. Yeah. So coming to agenda. So first of all, introduction to the K nearest neighbor. Then we'll discuss about KNN in machine learning and importance in automotive analysis. Finally, conclusion. So this is our agenda for today's session. So K nearest neighbor is one of the simplest machine learning algorithm based on the supervised learning technique. Okay. So in simple words, I can say, so if I know about your neighbors, so I can predict about you. Yeah, so the new data point, so category will be find out by the neighbors. So if I know about the neighbors, I can say, so which it is belongs to. So it is assume similarity between the new case data and available cases and put the new case into the category. And even it is also called as lazy learning. KNN, it is also called as lazy learning. So I can give some example how KNN will work. Suppose if tomorrow we are going to write one examination. So up to now, we did not prepare anything. Then we can spend some time around 4 hours or 5 hours on one today, and we can write examination. So then even though after we can get good score the particular examination, that is because of just learning. So we are not training everything, just try to remembering the entire data set. That's why it is called lazy learning. So same way, so KNN is whenever we load the data, try to remember the data set, try to memorize the data set to give the results. Okay. And similarly, in that case, if we after some times we forget everything what we prepared for that examination. That's why it is also called as lazy learning. So instead of training the data, it tried to memorize the data. And it stores all the available data and classifies new data point based on the similarity. So suppose you can take this example. So there will be a data point, suppose 1, 2. Yeah, suppose there is another, this is one data points. So when a new data points come, now we try to find the distance so between the existing data points. So before that we need to define the number of neighbors. So here in KNN, K is nothing but number of neighbors. So number of neighbors basically we can choose, so 1, 3, 5, 7 odd numbers. So we can choose the neighbors. Suppose here these 2, 3. So let us, I am assuming these 3 are the nearest neighbors. Now then we can calculate the Euclidean distance. So between data points to our new data point. So in this case, if you clearly observe 2 data points from the right side, so 2 neighbors are 2 data points are nearer to the new data point. So we can say our new data point is belongs to that category. So in this way it will work. Yes. So it stores all the available data and classifies a new data point based on the similarity. So it tries to store the data, and when the new data point is comes, so it tries to find the similar data point with respect to new data point. This means when new data point appear, it can be easily classified into good suit category. So when new data points comes, so it can predict which category it belongs to based on similarities, and can be used for regression as well, not only for classification, but mostly it is used for classification problem. So regression is nothing but there will be a formula, so number of input variables and one dependent variable. So we can find the relationship between independent variables and dependent variables. No. So what is the procedure to implement KNN in machine learning? So KNN can be explained on the basis of the below algorithm. So this is the algorithm is mentioned. So in the step 1, we can select the number of K of the neighbors. So number of neighbors, K stands for the number of neighbors. So default it will be 1, 3, 5, 7 and so on. And calculate the Euclidean distance of K number of neighbors. So we can find the distance between data points with respect to the one new data point, and suppose 5 data points we have chosen. We have chosen number of neighbors is equal to 5. So then we can calculate so distance between the new data point to the existing the 5 data points. Now which will give the less distance, and where we can compare. So 5 neighbors. Suppose right side 3 neighbors, left side only 2. So we can consider it is nearer to the right side one. But take the K nearest neighbors as per the calculated Euclidean distances. So the neighbors will be chosen by the Euclidean distance. Among these K neighbors, count the number of data points in each category. So assign a new data point to that category for which the number of neighbors is maximum. Suppose number of one side number of neighbors is 5, another side 7. So number of based on the maximum. Finally, our model is ready. So why we need to do KNN algorithm? So there is one example is given. Suppose there are 2 categories. You can see the below images, category A and category B. And we have a new data point X1. You can see in the below diagram, left side diagram. So this data point will lie in which of these categories. So to solve this type of problem, we need a KNN algorithm. See, so we have one example, 2 categories. We can easily understand different points are present, category A and category B. Now in category A, category B separated with different colors, so you can understand. So before KNN, there is a new data point. I think you can able to see in blue color. Now we need to decide. So it belongs to which category? Is it belongs to category A or category B? So after applying K, what we can do? First, we can choose the number of neighbors. We can choose the number of neighbors. Now this is the data point. Now if you observe, if you choose number of neighbors, you can notice that and the Euclidean distance and number of neighbors data point assigned to category 1, because the neighbors maximum neighbor left side and the Euclidean distance also less. So the new data point is belongs to the category A. So in this way, KNN will work. It is very simple. So importance of KNN in automotive analysis. So where we are using KNN? So car companies can analyze their So car companies can analyze their existing customers to identify the characteristics that predict a purchase. So who are the existing customers? Like that. So based on that, they can improve their productivity. And cross validation involves and nothing but using different hyperparameters by k-fold cross validation equal repeated random subsampling. So these are some hyperparameters techniques to improve the accuracy of the model, and proposed method may have high bias. High bias means when the number of k is increases. Actually, if k value is maximum, so that will give the good value. But if it is more, so it leads to overfitting. So its performance may be poor due to the high variance. So accuracy with the proposed KNN classifier was less than the existing KNN classifier. And the smaller the improvement in runtime, the larger the improvement in precision and recall. So here we have precision and recall. So precision is nothing but precision so it is one of the indicators of machine learning model performance. So it refers to the number of true positives divided by the total number of positive predictors. Yeah. So number of true positives divided by the total number of positive predictions. So here we can predict the values. So precision we can calculate, and larger the improvement in precision and recall, and there is recall. So recall is nothing but percentage of total relevant results correctly classified by our algorithm. So we can say percentage of total relevant results correctly classified by our algorithm. So this is nothing but recall. Percentage of total relevant results correctly classified by our algorithm. So these two are very important. So if we improve, definitely our model can work fine. Now, coming to conclusion, so it is one of the many lazy learning algorithms that don't base predictions on a learning model. So it is also a lazy learning algorithm, makes predictions on fly just in time by averaging the similarity between an input observation and the data is present. So based on the similarities, so it will give the result. Yeah, so this is KNN, also lazy learning. So let us discuss about hands-on. Yes. So as we discussed, KNN is one of the most simple algorithm in supervised learning. So in this example, we shall see how to classify and predict cars. Now, how to classify the cars, predict the cars using the KNN algorithm. Now for the first step, we need to import the necessary libraries. So import numpy as np, pandas as pd. So numpy, so working on arrays, and pandas for data frames. So we need to import these two. Let us run. Done. So after we need to import k nearest neighbor classifier. So it will for our implementation of our model, and we need to import train test split, and from stlen.metrics import confusion matrix classification report and pre-process. So these are libraries are required for our implementation of algorithm. So now let us read the data. So we have empty cars data. So if you want to see the data, just we need to load the data. So we can load by pd.read_cs. So this is the command to load the data. Now once we need to check the data set. So cars.head. So these are the different columns: model, MPG, cylinder, this HP, drought, WT, Q second, VS, AM, gear, cop, etc. So these are the various columns. So let us take some particular columns, and output is so here you can have one column that is nothing but AM. So AM was the range of automobiles manufactured by the you can say one of the measurement. Now we need to classify based on that. So first let us checking our missing values. Any values are present in our data set or not. So that will be verified by is null.sum. So there is no any value present in our column, so it is fine. So let us execute. Select some values for x as well as y. Fine. Now splitting the data into the train and test. So 70-30, so 0.3. Random state is 10. So next we need to check our training data. So here random is nothing but a lot of numbers of set generated randomly in an operation. So training data shape consisting of 22,5. Then we are going with model KNN, K nearest neighbor classifier 1. So training the model. Just only training is done. So now let us do the prediction. So what is the confusion matrix? So this is a classification report. So we have one metric, precision, recall, F1 score, support. So here in that metric, just I can say as a informed, so precision. So it is one of the indicator of a machine learning model's performance, and it refers to the number of true positives divided by the total number of positive prediction. Coming to recall, so it is percentage of total relevant results correctly classified by our algorithm. Next, F1 score. F1 score. So F1 score is nothing but harmonic mean of precision and recall. And again, we can have what is harmonic mean. So harmonic mean is nothing but so it is nothing but dividing the number of observations by the reciprocal of each number in the series. So number of observations by the reciprocal of each number in the series. Simply we can say adding of both. So this recall and F1 score average is nothing but F1 score. And finally we have one more that is nothing but support. So it is the number of actual occurrences of the class in the specified data set. Number of actual occurrences of the class the specified data set. Okay, so from this example, so a simple example regarding k-nearest neighbor, it is clear that so we have achieved an efficiency 93%. Yes, it's okay, good. So in this way we can implement k-nearest neighbor algorithm for cars data set. So once I will revise. So today we discussed about one of the use case, one of the machine learning algorithm. So that is supervisor algorithm. Supervisor algorithm is nothing but we have output variable and label data. So that is KNN, and so it is also nothing but a lazy learning, because it is one of the simplest machine learning algorithm, so based on supervised learning technique. And here data points, so there will be data points. If there is a new data point comes, so new data with respect to the new data point, initially we can have some neighbors. So the neighbor generally 3, 5, 7 like that. Now, after deciding the number of neighbor, we can find the Euclidean distance. So Euclidean distance formula is under root of x2 minus x1 whole square plus y2 minus y1 whole square. So with this Euclidean distance formula, so distance will be calculated. And suppose after calculating the distances, if you find the right side, there will be less data points. So right side only 2 data points are belongs to the particular new data point, and left side there will be 3. So based on the maximum number, so we can decide it is the new data point is belongs to the left side category. In this way it will work. Yeah, I explained, right? For our examination, just we can prepare and we can present. So after 2 or 3 days, we can forget everything. Same way. So instead of training, it will try to memorize the data set. So KNN try to memorize the entire data set, and based on that, it will give the results. When new data point is comes, it will give, so the so and so data point is belongs to the particular category. And these are the steps. So implementation of steps in KNN. So first we need to select the number of K. So number of neighbors we need to select. Then we need to calculate the Euclidean distances with respect to K number of neighbors. So number of neighbor as per the calculated Euclidean distance. So based on the distances, we can take neighbors like 3, 5, 7. Then take the K nearest neighbor as per the Euclidean distances. Suppose if 2 data points are having less distance and right side 3. So that which Euclidean which data points have the less Euclidean distance. So based on this, we can decide the number of neighbors and count the number of data points in which category. Suppose left side is more data points, then it is belong to the left side. If it is right side, then right side. So then our model is studied. This is one example. So why do we need a KNN algorithm? So before KNN, just there will be the data points, 2 categories. So when a new data point is comes, so based on Euclidean distances, we can give the category. So when new data point is belongs to this category, category A or category B. From this example, it is clear that a new data point is belongs to the category. So in how it is helpful in automotive industry. So KNN as per nearer algorithm. Like suppose if one vehicle will behave like it is damaged after traveling some kilometers. So based on similarities, we can predict same mission will damage, same mission will function like that, etc. So in this way, KNN will be implemented in automotive analysis. So finally, coming to the conclusion, it is one of the many lazy learning algorithm. Don't base predictions on learning model, and just it is make predictions on the fly. So make predictions on the fly, nothing but just in time by averaging the similarity between an input observation and the data already present. So this is KNN. So today we started supervised learning algorithms, and tomorrow we can come with one more algorithm, that is nothing but decision tree. Okay, thank you for joining. Have a nice day. Bye.